It's time for Maths with Mr. Thomas.
Hey, hey! Here is chapter 15, lesson number 4, looking at log rules. Last lesson we were looking at logarithms, really converting between logs and exponentials. And what we're going to do now is look at the rules associated with logs. Yeah. So, different rules then. If you have log base a of x plus log base a of y, well, you can see the base is the same. So we've got log base a and log base a. If the base is the same, what can you do with the x and y? Well, you can multiply them together. So you can bring it together, so that will become log base a of x times y. If you are subtracting, what do you think you would do instead with the x and the y? Note that the base again is the same. What do you think, Chelsea? Good, you would divide, so you'd have a log base a of x divided by y. Perfect. Another rule, if you have a log base a of x to the power of n, something that you can do is you can take that index, the n, and you can bring that down right to the front. So that will be the same as n times log base a of x. So you can bring the index right down. Two others, we have come across these already. We looked at them in the other lesson. But if you have a log base a of 1, what is that equal to? Well, think about rewriting that in exponential form. If you had a to the power of something and you get 1, well, it's going to be a to the power of 0. If you have 0 as the index, that will always give you 1. And if you have log base a of a, well, again, if you think about rewriting that in exponential form, base bottom top, look back to the last lesson if you're unsure about that, but you would have a to the power of something would give you a, well, it's just a to the power of 1. A to the power of 1 equals a. So let's look at applying some of these rules to solve some problems. So example 1, simplify log 6 plus log 4. Notice we are not given a base. If we are not given a base, generally it means log base 10, but if we're not given it, we don't write it either. So it's just log 6 add log 4. Really means the base is going to be the same. So what would you do with the 6 and the 4? Well, using your log rules here, we have log base a of x plus log base a of y. If the base is the same, which it is here, there's no base, then you would take the x and the y and multiply them together. So take the 6 and the 4 and multiply them together. So you'd have log base whatever of 6 times 4, which will give you log 24. Next one. Example 2, simplify log base 10 5 plus log base 10 2. Again, you notice the base is the same. We've got log base 10 and log base 10. So what can you do with the 5 and the 2? Yeah, just like the last example, just like this rule up here, take the x and the y and multiply them together if the base is the same. Base is the same, so take the 5 and the 2 and multiply them together. So you'd have a log base 10 of 5 times 2, which is obviously log base 10 of 10. Can you take that any further? Andrew thinks you can. Andrew, what would that be equal to? 1. Yes. Why? Brilliant. It's one of your other rules. If you have log base a of a, in other words, if the base is the same and this number is the same, then that will be equal to 1. So log base 10 of 10 will be equal to 1. Again, if you maybe think about rewriting this in exponential form, if that was equal to something, it'd be 10 to the power of what equals 10 is 10 to the power of 1. So that does give you 1. Example 3, simplify log 16, take away log 2. What do you think we can do here? Madiha, help us out. Brilliant, well done. If it's the same base for logs, here there's not a base given, so really it just means log base 10. Don't write that though. If you're not given a base, don't write a base. So you'd have log 16 take away log 2, which would become log 16 divided by 2, just using this rule here. So log base a of x take away log base a of y. If the base is the same, it'll be x divided by y. And you can put them together. So it'll be log 16 divided by 2, which will be log 8. Woo! Next one, example 4, simplify. Log base 6 9 plus log base 6 8, take away log base 6 2. So here, really we've got 3 terms. So what would we do? Well, if you think about just the first two, we've got log base 6 9 plus log base 6 8. Well, you're adding here and the base is the same. So when you're adding and the base is the same, you multiply the x and the y together. So we'd have log base 6 of 9 times 8. But then we're subtracting log base 6 2. And when you're subtracting, then it would become divide. So really what we've got, if you put them all together, you'd have log base 6 9 times 8. And then you're dividing by 2. Notice it's log base 6 in each of them. From there then, you would work out no you wouldn't. You would work out 9 times 8 divided by 2, which will give you 36. From there, you'd have log base 6, 36. To work that out, what you would do is you would just set that equal to something. We did this in the last lesson. If you're unsure, just go back to that. And then rewrite it as an exponential. We want to find out what this is equal to. So I'm going off to the side, setting it equal to x, and then rewriting it in exponential form. So think base, bottom, top. The base is the 6. You can see that there. Draw a line at the bottom across to the other side. So it'll be 6 to the power of x. And that will equal, draw your line at the top. So that equals 36. Base, bottom, top. Covered loads in the last lesson if you're unsure. From there then, 6 to the power of what gives you 36? We know that's equal to 2. And you took the log base 6 of 36, said that was equal to x, x was equal then to 2, so you know log base 6 of 36 equals 2. So we've just gone off to the side to work out what that would be. Number 5, simplify log 3 plus log 1/3. Again, we're not given a base, just imagine it's log base 10. Either way, the base will be the same. When you're adding, what do you do with the 3 and the third? Good, you'd multiply them together. So it's log and then 3 times 1/3. 3 times 1/3, well, 3/3 is going to be 1 whole, so it's just going to be log 1. Again, if you think about it, no matter what base you have, if you rewrote that in exponential form, you'd have something to the power of what would give you 1. Well, it's always going to be to the power of 0. Anything to the power of 0 will give you 1, so that will just be 0. Again, it's one of your log rules just up here. Log, base, whatever, of 1 equals 0. So if we get a 1 there, it's always going to be equal to 0. Example 6, simplify log base 3 of 9, take away log base 3 of 1/3. Here, what would you do? Good, you're going to be dividing because the base is the same as log base 3 and log base 3. So, when you've got the same base and you are subtracting, well, you divide the x by the y. So you divide 9 by 1/3. Dividing by 1/3 is the same as multiplying by 3. So that's going to be 9 times 3, which is 27. And now we've got log base 3 of 27. We need to work that out, so go off to the side and just let that equal something. It's difficult to work out when it's in log form, so rewrite it as an exponential. So rewriting in exponential form, think base, bottom, top. The base is 3. Draw a line at the bottom to the other side, so it'll be 3 to the power of x, and that will equal 27. After that, 3 to the power of what is 27? Good, it's going to be 3. Therefore, you know log base 3 of 27 is going to be equal to 3. So you can go back over here and say that's equal to 3. And that will be your answer. Next one, example 7, simplify log 4 plus 2 log 3. Here, very similar to the other examples, but we've got this 2 in front of log 3, which poses a bit of an issue. How could we maybe get rid of that 2 or maybe move it? What rule could you use here? Perfect, yeah, you can use this rule here. If you have some number in front of log base a of x, what you can do with that number is you can move it up here, so it will become the index for the x. So you can just move it up. So what we want to do is we want to take that 2 and we want to move it to become the index. So it'll be 3 to the power of 2. So in other words, we'd keep the log base 4, move the 2 up, so it becomes log base well, there's no base there, and then you'd have a 3 squared. From there, what could you do next? Yeah, good, 3 squared, don't leave it as 3 squared, you know that's equal to 9, so you'd have log 4 plus log 9. Again, with this, you don't have a base given, so you're imagining it as log base 10. Don't start writing that in though, just leave it as it is. But either way, the base is the same, so what would you do with the 4 and the 9? Good, you go back up to this rule here, so multiply the 4 by the 9, so you'd have log 36. And that will be your answer. Example 8, simplify log 2 plus 2 log 3, take away log 18. So Hannah, what do you think you would do first? Good, well done. With this middle term here, you've got this 2 in front of log, which causes issues. So what you want to do is you're wanting to move that up here, so it will become the index for the 3, so you'd have your 3 squared. Perfect. So keep log 2 as it is, take away log 18 as it is, but move this 2 up, so you'd have log 3 squared. Perfect. What would you do after that then? Good, work out 3 squared, that's going to be 9, so log 2 plus log 9 is just 3 squared, take away log 18. From here, well, again, the base is going to be the same. So when the base is the same and you're adding, then you want to multiply the x and the y. So here, when we're adding, we'd multiply the 2 and the 9. And then when we're subtracting, well, you'd divide the x by the y. So you would do 2 times 9 and then divide that by the 18. So you'd have log 2 times 9 because we're adding them. And then we're taking away the 18, so you're dividing by that, just using these two rules here. From there, 2 times 9 is 18. 18 divided by 18 is going to be 1. From there, Connor, log 1 is going to be, good, it's just going to be 0. Again, if you think about that just in exponential form, if you had a base, something, your base to the power of something is going to be 1. Well, anything to the power of 0 gives you 1, so you're just going to get 0. Or you're just using this rule here. Well done. Example 9, simplify log of 1 over x. So with this one, what could you do with that? Good, yeah. One way of doing it is to take this x, well just now it's x to the power of 1. What you can do though is you could rewrite that. You know you can move this x to the power of 1 up to the top line using your rules for indices. If you move that up then, that will give you log of x to the power of negative 1. What could you do after that? You could simplify it a little bit more. Good, using this rule here, if you have an index of its log base a of x to the power of something, well here it's log base whatever, x to the power of this negative 1, what could you do with the index? Yeah, just move it down to the front. So move the n right down to the front in front of log. So here move the negative 1 down to the front in front of log, so you would end up with negative 1 times log x, or just negative log x. So that is one way of doing this. Another way to think about it is, well, take this rule here. If you have log and then you're going to be dividing x divided by y, well here we've got log and we're dividing, it's 1 divided by x. What you could do is you could reverse this rule. So that will be log x, take away log y. So here if we've got 1 over x, well we know if we rewrite that, that'll be log 1 take away log x. So we can also go down that route. How does that help us? Well, log 1, think about the rules. Log 1 is always going to equal 0, so that will be 0 take away log x, and 0 take away log x is just negative log x. So you can think about that one two different ways. It doesn't matter which way you think about it. Example 10, simplify log x cubed, take away 2 log x. Again, there's a couple of ways to do this. Which way would you be doing it, Andrew? Good, yeah, you could take this index. So if you take the 3, you could move that right down to the front. It is one of the rules, so put the 3 in front of log. So using this rule here, the index of its x to the power of n, move the n right down to the front. So it'll be n log base a of x. So here move the 3 down, so you'd have 3 log x, and then keep this, take away log 2 log x. From there you've got 3 log x, then you're taking away 2 log x. Well, you've got 3 of them, then you're taking 2 away, so you're only left with 1 of them. So you're left with 1 log x. Another way to do that, anybody do it a slightly different way? Yeah, what you could also have done is you could have taken this 2 and you could have moved that up to the top, so that would become the index. So instead of moving the 3 down in front of log, instead of doing that, what you could have done is taken the 2 and moved that up to become the index. So take this n and then move that up to become the index. That is one of the rules. So that would have given you then log x cubed if we kept that as it is, and then you'd have take away log x squared if you moved that 2 up there. From there, well, the base is the same. We've got log something, take away log something. What do you do with the somethings? Well, you can see from this rule here, you're dividing. So it'll be log x cubed divided by x squared. And obviously, x cubed divided by x squared gives you x. So it'll just be log x. And that will be your answer. Next one, example 11, simplify half log base 10 of 100. Again, I've given you two different methods. There's a couple of ways to think about this. So there's not always just one correct method. You can do it different ways. Find whichever one works for you and do that. So for this one, any suggestions? Yeah, if you've ever got a number in front of log, it's sometimes best moving that up. So that will become your index. So you'd have log base 10 of 100 to the power of 1/2. So that is one way of thinking about that. From there, what could you do, man? Yeah, good. The power of a half just means the square root. So that'll be log base 10 of the square root of 100. Iman, square root of 100? 10. Good. So you'd have log base 10 of 10. And remember, one of the log rules, if you have log base a of a, that's equal to 1. So here, log base 10 of 10 will be equal to 1. Again, you could always think about rewriting it in exponential form if that was equal to something. 10 to the power of what is 10? Well, it's 10 to the power of 1. So 1 will be your answer. As I said, you could have done this a slightly different way. Anybody want to tell me what they would have done? Yeah, good. You could rewrite 100. If you think about 100, well, 100 is the same as 10 squared. So you could have thought about that as half log base 10 of 10 squared. From here, well, you could think about it two different ways. Either you could think, well, you've got log base 10 and then you've got exponential base 10. So log base 10 and exponential base 10 will cancel out, leaving you just with a half times the 2, because log base 10 and exponential base 10 will cancel. Or you could think, well, I'm taking the index and moving that down, just using this rule up here. So the 2 will come down, so it's half times the 2, and then you'd have log base 10 of 10. If you did that, well, log base 10 of 10, log base a of a is equal to 1, so it's just a half times 2 times 1. Different ways to think about this, as you can see. Hopefully, though, you get the same answer each time. Half of 2 is obviously 1, so that will be your final answer. Example 12, simplify log base 2 of x plus 1, take away 2 log base 2 of 3. So with this one, what would you do? Yeah, if you've ever got a number here in front of log, you're best to move that up, so that will become your index. So move that up, well, because you're just working with numbers here, you could then simplify it. So keep log base 2 of x plus 1 as it is, and then rewrite this as take away log base 2 of 3 squared. You're just moving that 2 up to become an index. From there, the whole point in doing that, why would we do it, Matthew? Yeah, because you could work out 3 squared. It's dead easy. 3 squared is just 9. So rewrite that as log base 2 of 9. From there, what would you do next? James, help us out. Yeah, good. The base is the same. When the base is the same and we are subtracting, you will divide x plus 1 divided by 9. We can't do anything further with that, so that will be your answer. Well done, James. Next one, log. Example 13. If log base 2x plus log base 26 equals 5, what's the value of x? So with this one, any ideas? Good, yeah, the first thing you want to do, you've got a log base 2 and log base 2. So the base is the same and you are adding. If the base is the same and you're adding, what do you do with the x and the y? Well, you multiply them together. So applying that down here, we've got an x and a 6. What do? Well, you multiply them together. So it becomes log base 2 of x times 6, which is 6x, and that's equal to 5. From there, how would you work out x? What would you need to do? Brilliant, you would rewrite that in exponential form. So in exponential form, think base bottom top. It's log base 2. So start with the base, draw a line at the bottom to the other side. So in exponential form, it will be 2 to the power of 5, and that will equal the 6x. Think base bottom top, which we covered in the last lesson. So you'd have 2 to the power of 5 equals 6x. From there then, good, yeah, just work out 2 to the power of 5. 2 to the power of 5 is 32. I'm going to rewrite that as well, put it back to front. I want to finish off with x equals, so just rewriting it. So to have 6x equals this 32. From there then, to get x on its own, you divide both sides by 6. And from there, well, you've got 32 over 6. That would simplify to 16 over 3. And that will be your final answer. Woo! Next one, example 14. If log base ay equals log base a4 plus 2 log base ax, express y in terms of x. So what's the first thing that you would do with this one? Anybody want to tell me? Well done, yeah, Chelsea, I would do the exact same thing. If you have a number in front of log, here you've got this number, you've got the 2 in front of log, so move that up. So that will become an index, just using this rule here. A number in front of log will move up to become an index with this x, so it'll be x to the power of n. So moving the 2 up, keep the log base a of y, keep the log base a of 4, and then move the 2 up, so you'd have log base a of x squared. Perfect. What would you do after that then, Chelsea? Take it one step further. Yeah, good. You're adding here, you're adding log base a of 4 and then log base a of x squared. When you're adding and it's the same base, you can multiply them together. So it'll be 4 times the x squared. So we'd have log base a of y equals log base a of 4x squared. What you're doing now? Well, really you can cancel a log base a from both sides. You have y equals 4x squared. I suppose the correct mathematical way of doing it though is if you're doing the same thing at both sides, you would take the exponential of base a at each side. So exponential base a of log base a of y equals, that would be a to the power of log base a of 4x squared, and then from there exponential base a and log base a will cancel out. You could, I suppose, just go straight to that. Y equals 4x squared though. That'd be absolutely fine. That is then y written in terms of x. You have y equals and x is just on the right hand side. So that's your answer. Example 15. If 2 log base 3y equals log base 3x plus 5 plus 4, show that y squared equals 81 bracket x plus 5. So for this one, definitely a bit trickier. Anybody have any suggestions for what you could do? Yeah, good. The first thing I would do is take the logs just to one side. So here I've got log base 3y squared. If I move this log base 3 of x plus 5 to the other side, then really I'm going to take away log base 3 of x plus 5 on both sides. So either think about moving that over to the other side, so the positive will become a negative, or take away log base 3 x plus 5 on both sides. From there then, good, yeah. What you could do, you've got log base 3 of y squared, take away log base 3 of x plus 5. It's the same base, you are subtracting, so you can put them together. So it'll become a log base 3 of y squared divided by this x plus 5. From there, we are wanting to show what y squared is equal to. How would we do that? Well, if you notice in our answer, we don't have any logs. So we need to rewrite this in exponential form. So to rewrite that in exponential form, again, think base bottom top. It's log base 3. So in exponential form, base bottom, draw a line at the bottom to the other side, then draw a line at the top, back across the equal sign. So you would have 3 to the power of 4 equals this y squared over x plus 5. From there, what could you do next? Yeah, don't leave 3 to the power of 4, it's 3 to the power of 4. You know that's just going to be 81. 3 times 3 times 3 times 3 gives you 81. From there, you want to get y squared on its own, so multiply both sides by x plus 5, and that will give you y squared equals, well, you've currently got the 81 on this side, multiply that by x plus 5, don't forget your brackets, and then you'd have the 81 times x plus 5 equals y squared, or in other words, you are asked to show that y squared equals that, so rewrite it and say y squared equals 81 bracket x plus 5. Just leave it in the form that they are asking for, and that will be your answer. Hey, hey. Next one, example 16. If log base 3t equals 2 plus log base 3,5, what is the value of t? Any suggestions for what we could do here? Yeah, well done. I would do the exact same thing. Move the logs to the same side. So subtract log base 3,5 from both sides. So that's what we're starting with. Subtract log base 3 of 5 from both sides, or move the log base 3,5 across to the other side, so the plus will become a minus. And from there, what could you do next? Good, use your log rules. We've got log base 3t, take away log base 3,5. It's the same base, we are subtracting. So when we're subtracting, we divide, so it'll be t divided by 5. So we'd have log base 3 of t divided by 5, and that will equal 2. From there, it's difficult to work out what t is when it's in log form, so rewrite that as an exponential. Olivia, help us out. What would that become? Brilliant. Well done. If you rewrite it in exponential form, thinking about base bottom top, Olivia, you are perfectly right. It'll be 3 to the power of 2, and that will equal t over 5. Perfectly right. Good. From there, where could you go next, Liba? Yeah, 3 squared, just work that out. 3 squared is obviously 9, so you'd have t over 5 equals 9. And then from there, to get the value of t, well, multiply both sides by 5. Therefore, t would equal 45. Woo! Next one, example 17. Solve the equation log base x of 8 plus log base x of 4 equals 5. With this one then, how would you start this one off? Good. What you notice is the base is the same. We've got log base x and log base x. When it's the same base and we're adding, well, what we can do is multiply these together. So it'll be log base x of 8 times 4. From there, 8 times 4 is going to give you 32. So we've got log base x of 32 equals 5. And then from there, well, if you want to work out x, it's difficult to work out when it's in log form. So once again, rewrite it as an exponential. Mary Lou, what would that be as an exponential? Good. You're going to have x to the power of 5 equals 32. So we're putting it in exponential form. Mary Lou is perfectly right. It'll be x to the power of 5 equals 32. From there then, to get the value of x, suppose you could work that out in your head. What number multiplied by itself 5 times gives you 32, and it is going to be 2. Brilliant, well done. You're really just taking the fifth root of both sides, so x would equal 2. One last one. Example 18. Given that log base 10 of e1 over e2 equals 1.5 times r1 take away r2, find e1 if e2 equals 10 to the power of 6, r2 equals 4.3, and r1 equals 6.3. Any suggestions with this one? What would you do first to work this out? Bally? Yeah, good. Just start substituting these numbers in. So replace e2 with 10 to the power of 6, replace r2 with 4.3, and replace r1 with 6.3. So you would end up with that if you're rewriting it. From there, what would you do next? Yeah, to do it one stage at a time. Here in the brackets, you'll notice you have a 6.3, take away 4.3. Don't leave it as that. You know that's obviously going to be 2, so rewrite it as 2. From there, what would you do next? Again, yeah, do these simple wee bits. So you've got 1.5 times 2. 1.5 times 2 is obviously 3. Excellent. After that, where would you go from there? Yeah, it's difficult to work out in log form, so rewrite it as an exponential. So, in exponential form, take the base, draw a line at the bottom across to the other side, and draw your line at the top back over here. So, you would end up with 10 to the power of 3 equals e1 over 10 to the power of 6. We are wanting to work out this value of e1, so multiply both sides by 10 to the power of 6, or move that over and then times. You'd have 10 to the power of 3 times 10 to the power of 6, and that will give you, good if it's the same base, add the indices. So that's 10 to the power of 9, and that will be your answer. That's it for log rules. Try these questions. Make sure you are 100% okay before you move on. If you're still unsure a wee bit about rewriting in exponential form from log form or vice versa, maybe go back to that previous lesson, try a few more of those questions. Once you're comfortable with that, try these anyway with log rules. Good luck. Bye.